So if you see, if you look into the Mars exploration, Mars exploration by NASA, so most of the parts are 3D printed parts, and yeah, if the parts fail in Mars, so they have their own 3D printer in Mars to produce replacement part for their usage. Okay, so the process of additive manufacturing are divided into three main process, which is the liquid base, powder base, and solid base. So most likely in the industry nowadays use powder base for metal additive manufacturing process, and plastic for solid base. So in PSAS we have fused deposition modeling, which use filament, ABS filament, and PLA filament to produce parts. And also we are currently in a process to procure laser sintering additive manufacturing, which can produce metal parts and components. Okay, so the process, the first one is stereolithography, which called as L, recognized as the first 3D printing process. It was certainly the first to be commercialized. So the process is laser-based, works with photopolymer resin that react to the laser and cure to form a solid in very precise way to produce very accurate parts. So a laser beam is directly in the X-Y axis across the surface of the resin. So this is, if you can look to the figure on the right hand side. So this is the resin part according to the data supplied to the machine, which is in .stl. So STL is the stereolithography format file, whereby the resin hardened precisely where the laser hit the surface. So the laser pointed into the resin and produced the part according to the geometry. So the platform within the vat drops down by a fraction in z-axis, and subsequently layer is placed out by the laser. So this is one of the initial 3D printing process before we go further into the FDM and SLS process. And then we have a digital light process, or which is called DLP. The process is similar to stereolithography in 3D printing process that work with photopolymer. The major difference between SL and DLP are the light source. DLP use more conventional light sources, such as an arc lamp with a liquid crystal display panel or a deformable mirror device, or this is applied to the entire surface of the vat. The photopolymer resin in a single pass, generally making it faster if compared to SL. Like SL, DLP produce high accurate parts with excellent resolution, but its similarity also include the same requirement for support structure and post repairing. The one advantage of DLP over SL is that only a shallow vat of resin required to facilitate the process, which generally result in less waste and lower running costs. So this is the vat part which hold the resin of the material that is used to produce the 3D printed component. And then we have SLS or SLM, a laser-based 3D printing process that works with powder materials. So the laser is traced across the powder bed of tightly compacted powdered material according to the data fed to the machine in the X-Y axis. So this is the powder section, and then we have the laser section that method that's used to melt the powder that later on produce the part for our 3D printing process. So as each layer of completed, the powder bed drops incrementally and the roller smoothen the powder over the surface of the bed barrier to the next pass of the laser for the subsequent layer that can be formed and fused within the previous layer. So every layer is fused, meaning that it creates a bonded connection between layers of the parts. The one key advantage of the process is that the powder bed serves as an in-process support structure for overhang, undercuts, and therefore complex shapes that cannot be manufactured in other way are possible in this process. And then we have fuse deposition modeling or free-form fabrication process. So FDM is the most likely term that can be used in either education institution or industry. So the 3D printing is utilizing the extrusion of thermoplastic material. It's easily the common recognizable 3D printing process. So if you can see in the figure, we have the filament, and then this print head is heated into specific temperature, and then the molten material, which is likely ABS or PLA polymer plastics, layered by layered, fused or deposited into the platform. So it forms the solidified model as you can see on the figure on the right hand side. So the FDM or FFF process requires support structure for any application with overhang. So if you can see the figure, most likely that this part here needs overhang, which this part here is the overhang, which need or required some support to print this part or a section that overhang from the model. So the process can be slow for some part geometries, and layer to layer adhesion can be problem in resulting in parts that are not watertight. So it depends on the machine. If we set the parameter to be fine printing parameter, it maybe can be watertight and the finishing might be good, but most likely that the process itself can be longer to be completed in comparison if we use normal or cost a layer of finishing. And then furthermore, we have limited object manufacturing. This system of developed by helices, layers of coated paper, plastic or metal laminates successfully glue together and cut to shape with a knife or laser cutter. Technique may be additional drilling, so it will be introduced secondary machining. The typical layers resolution for the material stock and usually few sheets of copy paper. Have binder jetting. So binder jetting, where the material being jetted is a binder, and the selective straight into a powder bed of the part material to fuse it and layer at a time to create a print required part. So this process most likely similar to SLS, but the advantage of binder jetting like SLS include the fact that the need of support is negated because the powder bed itself provides the functionality. So in comparison with FDM, binder jetting and SLS is much more better if we compare the support of the 3D printing part that during the process. The further distinctive advantage to easily add or full color palette to the binder. So meaning print difference of color in single comparison with a single head FF process. Okay, look into the so can be utilized for 3D printing process metal, food, sand, stick, human tissues, wax, and polymers. So it depends on your machine. If your machine, 3D printing machine can print food, so it as your material. You can print like car or plane, or you can print human tissue. Other people or in that have better looking or better representation of their body. So plastic is normal. We have ABS and PLA. So that is material that can be used for 3D printer and additive manufacturing process. So the first one we have nylon or polyamide. Okay, so this particular material utilize FDM process. Okay, and then stronger, flexible, durable plastic that can prove printing. It is naturally white in pre or post print. Use nylon filament. You can fit to the post printing part after the printing process completed. So this material can be combined in powder format with powder aluminium to produce another common 3D printing material for sintering, which is called alumite. And then we have ABS. So usually if we buy our material online or in shop, or this is the spec that we have to look after. We have to make sure the material is compatible with the diameter of the filament itself is compatible with the nozzle, with the print head. So to make sure that the printing process can be completed with our intention of using the CAD geometry. And then ABS is the common plastic used for 3D printing, and it is widely used for entry-level FDM 3D printers. So if you buy something from the online platform, most likely that ABS is the material that can be used for printing your parts or geometry. It is a particular and comes in white. It can have a white color. You can have ABS black or specific for the 3D printer. ABS can be bought in filament form from a number of non-proprietary sources, which is another reason why it is so popular. You can buy 3D printer filament from a company that produce only 3D printer filament instead of the total solution for 3D printers. And then you have PLA, a biodegradable plastic material that has gained traction with 3D printing for this very reason. So it can utilize resin format for the LP and SL process, and also in FDM process. It operates in variety of colors, which is has proven useful option for some application of the 3D printing process. However, it is not durable flexible as ABS. As you can see in the figure here, the first one is printed using PLA, which have the characteristic of more glossy like finishing. And then we have ABS. You can see if we compare to PLA, the finishing is not as glossy as PLA, and the nylon material, which is in the white form, the finishing is a bit of PLA, but the characteristic or the properties of the material is a bit different. And then we have metal material, raw material, which come stainless steel in powder form to the sintering and melting EBM process. So the color of the material usually comes in silver, plated with and bronze. We have titanium, which is likely to be applied in aircraft product design. And then we have aluminium and cobalt. So this is the metal-based industrial application. So the supplied material for usually comes in powder. It can be used in sintering, SLS, melting, and EBM process. So other than that, we have biomaterials. As I mentioned earlier, we can produce parts for our body. Let's say that we want to replace our ears. We want to improve our design for our nose or something like that. So we can print ourselves by using 3D or AM process. So living tissue are being investigated at a number of leading institutions with a view to developing applications that include printing human organs for transplant, for heart or liver, as well as external tissue for replacement body parts. So other research is focused on developing foodstuff, meat being the prime example. So instead of meat, we taken from chicken and cows and so on. So we can print our own meat to meet the demand of our own food consumption. And then food, we can print our own food. We can print design, complex design of food. We can print food that can replicate the taste of apples and meats and stuff like that. So chocolate is the most common and desirable. There are also printers that work with sugar, and some experiment with pasta and meat. Looking to the future, research has been taken to utilize 3D printing technology to produce fine balanced whole meals. So you can print a food that can cover a wide range of vitamins and the usage of and so on. And then go into the additive manufacturing risk, respiratory tract and lungs. So we have to use PPE to ensure that the particulate or the powder that produced after the post-processing process does not affect us. So we have to use like mask or something like that. We have to use special gloves and clothing to handle 3D printing process, especially for metal 3D process. And then the risk of eye damage handling metal. So this is similar like before. You have to use goggles and to process the post-processing using special compartment like in the figure shown in the slide. And then for FDM. So most of the 3D printing machine have HEPA-like filter to filter the emission from the process. So most likely that the pollutant produced from the 3D printing does not affect us, but we have to take precaution to ensure that the effect of 3D printing does not affect our health. And then regulation loophole. So this is discussed earlier. The first 3D printed gun is old news, but its ramifications are very important. Companies are propping up around the world attempting to sell these guns or the CAD design for them. So engineering firm like Solid Concept has 5 rounds out of first 3D printed metal. So in Malaysia we don't have any special regulation that regulates the produce of guns and weapons from 3D printing process. So this one of the area that maybe the government have looked into that can regularize the process of metal 3D printing process for weapons and guns and rifle and stuff similar to that. And then the AM for future, this is the last section. So additive manufacturing implants. So this is the replacement for can be utilized from 3D printing process for additive manufacturing process. You can replace parts from accident and stuff if you want to replace parts. You can use 3D printing parts which can replicate the original design from your bones and stuff similar to that. Okay, and then for automotive industry, so this is last year's news where Bugatti, which is the OEM for sports car or hypercar, which utilize additive manufacturing in producing 3D printing for brake calipers. So this is one of the ways or one of the applications that can be further developed or further enhanced to further mass produce additive manufacturing parts for industry, for automotive industry, or automotive application. And then in the figure shown in the right hand side is the bespoke or personalized interior design. You can design your own interior design. You can design your own plastic interior parts, and then you can further enhance the part, and then you can install the parts for your own use instead of using the parts that mass produced from the OEM. And then for lightweight design concepts, so this is one of my research that I've performed years before. So we can see that we can produce parts that can utilize quite lightweight design. So the first design is most likely from the conventional machining process, and the optimized design is can be produced by using additive manufacturing process, which is optimized by 50% of the original weight, but also can perform similarly as the initial design from the conventional machining process. Okay, that's all for our first session, first part of our session this morning. If you have any question, you may ask in your own language. You can use any of your English or Bahasa Malaysia or Bahasa Indonesia if you have any question. So I open open the floor to question. No? Any question? Any question from CAE lab? No? If you have any question, just on your mic and you can ask. All right. Any question? Okay. So can we take a break like 5 minutes, Puan Farah?
Okey, bisa saja. Betul ke? Boleh je. Kita take a break about 5 minutes. And then we will start again at 11:30 minutes. Okay? Jadi semua 11:30 minit ya, waktu Malaysia.
Okay, baik.
Okay.
Ada soalan ke? Kita semua tak nak tanya.
Albu, tutup yang present tu dulu Albu. Akak nak share something.
Okay.
Akak nak share poster. Tadi terlupa nak share. Ada soalan tu, Albu, ada soalan dekat chat daripada, oh ni daripada beberapa orang.
Okay, thank you for the question. The question is from Abdul Razak and Naina Muhammad. I don't know where Abdul Razak from, but I will answer the question. Can I know what is the difference between 3D printer and rapid prototyping? So actually, I did mention earlier in the slide, 3D printer and rapid prototyping are similar, but the term of rapid prototyping, the term formerly used to describe 3D printing process. So originally in 1980s, the first term is rapid prototyping. After several years, during maybe in 2010, the term of rapid prototyping seldomly used, and nowadays they use 3D printer and additive manufacturing term to describe rapid prototyping. But actually, both terms are similar, but rapid or RP most likely seldom used nowadays. Okay, thank you for the question, Abdul Razak. Okay, welcome. Welcome.
Satu lagi tu soalan tu rasanya daripada Kalis juga. Encik apa Dr. Kalis?
Daripada Kalis. Okay, just reminder to all participants today for our session this morning to fill up the
Oh, itu
attendance.
bukan soalan.
No, it's not a question. To fill up the
Okay.
attendance form in the chat, you can click the link in the chat button in chat section to fill up the attendance form. Thank you.
Okay, thank you. Membacakan for reading the reminder. So our speaker,
Okay.
can you start again?
Yep. Okay. Can we start for the second part of the session this morning? So let me share the slide first. For the second part, actually, is the practical aspect of the 3D printing process. So, boleh nampak slide? Dekat bahasa nice. Okay, so our second part, so the operation of the machine we have here in PSAS. So it involves machine setup and parameter setting. So the operation of the 3D printer consists of machine description, machine setup, print setting, calibration, and lastly we have Q&A. So we look into the machine description first. The machine we have here in our lab is Up Mini 2 from Time. The print technology that used for our 3D printer is fused filament fabrication or FDM, fused deposition modeling. The build volume is 11.9 by 11.94 by 11.9 cm. So the layer resolution in XY axis is 150 to 350 micron. And the nozzle spec is 400 micron or 0.4 mm. The temperature for the nozzle is maximum temperature is 299 degrees Celsius. The precision for the machine in Y-axis is 5 micron or 0.005 mm. For Z-axis, also similar as XY-axis. The print speed is 200 mm per second. Okay, the filament spec is diameter 1.75. The material for filament can be printed in 3D printer machine in in our lab is ABS, PLA, and CPU. So this is the overview of the 3D printer in CAE lab. Print volume here, inside here, and then we have the print head, okay, located inside the machine, and the machine itself is a closed compartment. We have a front door, and then we have our rear door, and then the top cover consists of magnetic top lids. We have two top lids here. If I can share you the machine. Can you wait for a second? If you can see at one cam, the machine at our lab near the door, and then our top cover for the machine. And inside we have the print head, which the material filament can go through the print head for printing. Okay. And also at the rear side we have filament insertion, and then we have a power connector and supply switch. And furthermore, at the front side we have LCD screen to control the printer locally at the machine. We also can control the machine from computer using software that is provided by Up Mini Studio. And then we have a handle and utilization button for initialization button for the initialized process of the print. And then this is the print head. You have fan, we have cooling adjustment knob, and then at the tip, at the bottom of the print head, we have a nozzle. So the nozzle is where the filament is melted and deposited onto the print board. So this is the arrangement of print head for the Up Mini 2 3D printer. So, and then we have the filament holder, which hold the filament spool inside the compartment of filament holder. We have tool drawer at the bottom of the holder, and then we have the spool, and then we have the holder lid or cover for the filament spool. Let me show you the filament holder. Okay, currently I'm holding so inside the filament holder, we have filament itself, which is white, and then the weight of the filament is 500 grams. The filament is produced by Up Mini fila meaning filament. So this material is produced by the same company that produced the 3D printer. So the quality is quite good compared to generic filament that that is sold online in online platform. Okay, I go back to my slide. Okay, next we have a mission setup. So to install the filament, guide tube is shown in blue. So we have, if you see just now, I show you the lid or the holder for the filament, and at one section here we have the outlet for the filament to exit from the holder to the machine. And then after that, the filament will be inserted into the print head, which here, right? And then inserted into the print head, and then the process of inserting the filament is quite straightforward, where you can control the process of inserting and extruding the filament using software interface in the computer. Later on, I will show you the process of extruding the material. The process, 6 process total, but actually quite straightforward. Just press and click a button to extrude and release material from the printer. And then this is the material that can be used for 3D printer in PSAS. We have PLA, PLA plus, ABS, and ABS plus. So the difference between this material are the print temperature. So we have to select correct material to print. If we select PLA, let's say that we select the parameter for material is PLA, and then the material itself actually ABS. So it might be some error or the print, the 3D printer, the part that we print maybe have some problems in the finishing or something like that. And then the bed temperature, which is the platform temperature. So for PLA and PLA plus, no heat is required for the platform or the board. But as for ABS and ABS plus, the temperature required for the board is 110 degrees Celsius. So further down below is the mechanical properties for each of every material that can be used in the printer. Okay, so we go for the print setting. So the print setting actually is the setting for our finishing of 3D printing parts. So in this print setting, we have layer thickness. So set the layer of thickness, and then fill. So we have a number of fill. We have shell of no infill, normal wall, and then we have surface, no top and bottom layers, no infill, single perimeter, and then we have hollow, which have like rib-like structure inside our part, and then we have big hole, loose fill, and solid fill. So among these 4, the solid fill parameter is most likely the higher the strength of 3D printed parts compared to hollow lah. And then we have quality, we have normal, fine, and coarse, And then preference for advanced option, we can look into it later on. And then geometry settings. All of these are provided by the solution provider, which is UpMini. So we can just download the software from the website and then install the software in your own computer. So this is the geometry setting. User interface. Okay, you have menu 1, menu 2, which describe the orientation of your geometry. You can manipulate your geometry inside the build platform. You can adjust the model based on your preference, but you have to ensure that every printing process must use minimum level of support to ensure that the material is in minimum usage. And then at the left hand side here, you have home, load, file, print, initialize, calibrate, and maintenance. So in load file is where you can load your geometry into the build platform, and then the print section here is for your print, and then you can simulate the slicing simulation in the print process, and then calibrate. You can calibrate your print head if the print head needed the calibration process, and lastly the maintenance. So later on we go through one by one. So you can rotate. This is the function for rotate. Later on I will demonstrate to you how to rotate geometry inside the build platform using Up Studio. And then this is scale. You can scale or you can resize your geometry inside the build platform using the similar software. And then you can also move your geometry in X or Y direction depending on your preference. Right. Furthermore, we have the preference no rough, meaning that printing without rough, no support, meaning that printing without any support or any support for our overhang of the geometry, and stable support, which is the support structure will be stronger but less easy to be removed. Usually we want the support to be easily removed so that we can have the printed part in very good condition. And then unsolid model,